All right, so again, 1,4b is solving quadratic equations using complete the square. So when we are done with today's notes, you'll have learned 3 different ways to well, 4 really, using, like if they're x squareds, right? One was if it's factorable. If it's factorable, you're going to factor it, you're going to split and solve by setting them equal to 0. The second was if you could square root both sides of your equation, and then you use that even root property, which says the plus and minus, to solve. The third was the quadratic formula, and then the fourth is this complete the square. Quadratic formula and complete the square work every single time. So if you had you were stuck, you couldn't factor it, you can't use the even root property, you can always use these methods, okay? Complete the square and quadratic. Complete the square gets messy. So there are times where I would pick it over quadratic just for the simplicity of it, and we'll kind of talk about that approach. But then there are other times where it gets really messy, and I would avoid it with all costs because there's fractions, adding, subtracting fractions, that kind of stuff. It gets to be a little bit messy, okay? But sometimes you don't get that choice. So you will be required to use each of those methods at some point because the test will say solve using this specific method. So you just want to pay attention, okay? Complete the square has these steps, and I mean, obviously this is a lot of words. We're going to do this in step-by-step process, but should you get stuck in your process, hopefully this kind of takes you back to where you're supposed to be. So the very first thing you're going to do is keep the x squared and the x term on one side of your equation and move everything else to the other side. So where in factoring we put everything to one side, complete the square, you put the ones that have the x's on one side and you push the constant to the other side. Then you're going to, if there's a number or even a negative attached to the x squared factor, you're going to factor it out, or even easier is divide each term by whatever that a is, whatever's on front of the x squared. Sophia.
When they say move the constant to the right side, which constant?
There's only one constant. The thing that doesn't have a variable is the constant. Okay. Yeah, so you're going to move it to the other side. So if there's something in the front of the x squared, you're going to divide every term by it, which means you're going to divide the x squared term by it. You're going to divide the x by it, and you're going to divide the constant on the other side, the equal side, by it. So you're getting rid of it. Then you're going to find what fills the space to make it a perfect square trinomial. And the way you do that is you take the b. Remember, the b is in front of the x. You take the b, so whatever this term is, you divide it by 2 and you square it. And then you're going to add that term to both sides of your equal sign to balance your equation. And then you can actually get rid of this because by dividing both sides by it, we won't need to do that step. Then the goal there, why adding that b over 2 squared, is to make it a perfect square trinomial. So after you've done that, you're going to factor the left side, which is going to be the perfect square trinomial. You're going to shortcut to factor perfect square trinomial is square root the first term, square root the last term, take the sign from the middle and then put it in those parentheses and square it. And then you're going to solve using the even root property. So it brings that back in. Sometimes complete the square is actually pretty easy, and I would choose it to be first, and I'll kind of talk about the approach on that, but then sometimes it gets really complicated. So you just got to know the types of questions well enough to be able to say, I'm going to avoid complete the square on this one because of the fractions, let's say, if you can. Obviously, if it says you have to use complete the square, you don't have that choice, but there are times when it's going to give you the option. All right, so we're just going to go step by step through this process. So step 1 is move the constant to the other side. So I'm going to add the 14 to the other side. I'm going to do x squared minus 4x. I'm actually going to leave a space here because I'm going to fill that in. Equals 14. So we move the constant to the other side. Step 2 is see if there's anything on the front of the x squared term. And if there is, divide all the terms by it to get rid of it. We're going to baby step ourselves into that direction. It's not there yet, okay? So I don't have to do step 2. Step 3 is find out what I'm going to fill that space with. So I take the second term. I can ignore the sign right now because I'm going to square it, so it will always go back positive. So for the actual term, you can ignore the sign. I'm going to take that term, which is 4, I'm going to divide it by 2, and then I'm going to square the result. Yep.
Okay, why do you do that step?
This is how you're going to fill in that space. We have to find out what's going to make the left side of this equation a perfect square trinomial, and this is how you do it.
So you always divide by 2.
Always divide by 2 and then square. Yep. So 4 divided by 2 is 2, and 2 squared is 4. And that is what I'm going to add to the space I left. And to balance this equation, I have to do whatever I did the left side of the equation, I have to do the right side of the equation, so I'm also going to add it to the other side. Okay, now the whole goal there was to make the left side of this equation a perfect square trinomial. So I can factor it easily doing square root first term. So I would square root the x squared, and I get x. Square root last term, square root of 4 is 2. Take the sign from the middle, which is a minus, put it in the parentheses and square it. Equals 14 plus 4, which is 18. Now I go back to my even root property method to solve it. The goal was to get the same thing squared on one side, right? Isolate that. Then I can square root both sides of the equation, putting a plus and minus on the right-hand side. And I'd get x minus 2 equals plus and minus square root 18. I can either simplify that now or I can wait, but it has to be simplified. So some people on the quiz forgot to simplify your square roots. 18 breaks down into 2 and 9, which is 3 and 3. That means a pair of 3's goes to the outside. And the 2 that doesn't have a match stays underneath. And then you're going to add the 2. So you can either put the 2 at the front, like this, or you could put the 2 at the end. Don't forget your plus and minus. And don't forget to simplify your square roots. So either of these would be fine for an open-ended question. If it was multiple choice, it'd be usually written by the first one, like they like to put the square root at the end. Sophia. We're just going to do it a bunch more times. Go to 2. What's step 1? Add the 1 to the other side. X squared plus 6x. Leave our space equals 1. Step 2.
Square root of 6x.
Before I get there, I want to look at the first term, right? And I want to make sure x squared is there by itself, and it is. Otherwise, I would divide by whatever's on the front. Now, I would take that 6, divide it by 2, and square it. 6 divided by 2 is 3, and 3 squared is 9. I'm going to add it to the left and add it to the right. Now the goal was to make that left side a perfect square trinomial, so we used the shortcut, which is square root the first term. I get x, square root the last term. I get 3, take the sign from the middle, put it in parentheses and square it. And that equals 1 plus 9, or 10. With me so far? We good? Yeah? Okay, now it's set up to solve using the even root property. I square root both sides of the equation, not forgetting my plus and minus on the right. The square and the square root cancel. I get just x plus 3 equals plus and minus square root 10. And then subtract the 3. And I get x equals negative 3 plus and minus square root 10. Or plus and minus square root 10 minus 3. Either one. And 10 is just 2 and 5. It doesn't break down at all, so it will stay just like that. All right. Yep.
How did you do the last part?
All right, go to 3. Step 1. Add the 5. Leave the space because we're going to fill it in. Step 2. Checking. There's nothing there yet. So I'm still good to go to step 3. Take that 2. Divide it by 2. Square it. 2 divided by 2 is 1. 1 squared is 1. I'm adding the 1 to the left and to the right. Factor the left side. Square root the x squared. Square root the 1. Take the sign from the middle. Put it in parentheses and square it. And then 5 plus 1 is 6. Now I square root both sides, putting a plus and minus in front of the root 6. And I get x plus 1 equals plus and minus square root 6, which would just be 2 and 3. Nothing repeats, so it doesn't get simplified. And then I subtract the 1. So it can be plus and minus square root 6 minus 1, or it could be negative 1 plus and minus square root 6. I would tend to pick complete the square if there's nothing on the front and the middle term's even. If there's nothing on the front, middle term's even, this is not awful, okay? And I might pick it over quadratic formula, which would be your only option if it's not factorable, okay? But obviously it's going to get complicated. You're going to get things like on the bottom, 6 and 7, where you've got a leading coefficient this time. So we're going to do those obviously, but that, if I could avoid it, I probably would. Or ones in which like 4 and 5, that middle term is not even. So when I divide by 2 to find that third term, I'm dealing with a fraction, okay? It's still not awful because you would have had a fraction underneath the quadratic formula too, but maybe I would choose quadratic formula over complete the square if I had that option, okay? So with 4, still no leading coefficient. So first step is still the same. Move the 12 to the other side. Then I look at my middle, or I look at that first term. There's nothing there, so I don't have to take anything out or divide anything by it. But now my second term is not even. So when I do 7 divided by 2 and then square it, I do not want to turn 7 over 2 into 3.5 or 3.5 and then square it. You want to leave it as 7 over 2 and then square them individually. So that becomes 49 over 4. And then that is what we're going to add to both sides of your equal sign. Then if I did it right, I made the left side a perfect squared trinomial. So I'm going to square root the x squared, I get x. And I square root the 49 over 4, which takes me back to what's inside those parentheses, which is 7 over 2. And then I take the sign from the middle and I put it in parentheses and square it. And then on the right-hand side, I have to find a least common denominator and combine these together. So I'm going to change negative 12 over 1 to be something over 4. So I have to multiply by 4. And I get negative 48 over 4 plus 49 over 4, which is 1/4. And then I even root. Square root the left side, square root the right side, putting a plus and minus around. I get x plus 7 over 2 equals plus and minus. And this splits into square root 1 over square root 4. What's the square root of 1? 1. What's the square root of 4? 2. Yep.
Why does it go back to 7 over 2?
Because you square root the 49 over 4. So the square root of 49 is 7, and the square root of 4 is 2. All right, then I'm going to subtract the 7 over 2. And I get x equals, and again, it could be either order, but plus and minus 1/2 minus 7 over 2. Yep.
I'm sorry, how did it turn into?
Okay, so now what's different this time that hasn't happened before is there's no square roots left here, which means we actually have to keep going, okay? If there's no square roots, this actually means this would have been factorable from the beginning, okay? But if there's no square roots, you have to keep going. You can't leave that separate. That can be simplified. I can take this and divide it into two. One where it's a negative 1/2 minus 7/2, and one where it's a positive 1/2 minus 7/2. And I get negative 8/2, which is negative 4, and I get negative 6/2, which is negative 3. So the answers there are negative 4 and negative 3. Now, if you look back to your original question, this is factorable, and it would have been a lot easier to factor it out, right? So I would say if you're given an option and you can look at that original one and say, are there factors of 12 that sum to 7? And the answer is yes, do it that way. It's just that you're not always going to be given that option. All right, go to 5. So we're going to practice complete the square, but if this was just a test and it just said solve, I would see if there were factors of negative 6 that sum to negative 3. There's not, so I couldn't have factored it because that should be the easiest and quickest way. Which means I would probably go, because that middle term's odd, I would have done quadratic formula. But you don't have a choice today. We're going to do complete the square, okay? So I would move the 6 to the other side, x squared minus 3x equals 6. Look to see if there's something on the front. There's not. So I take the middle term, 3, divide it by 2, and square it. I ignore the sign because I'm always squaring it, which makes it always positive. 3 does not go, or 2 does not go evenly into 3, so I'm going to leave that fraction, but then square it, so this would be 9/4. And that's what you're going to add to the left and to the right. Then on the left, I square root the x squared. I square root the 9/4. I take the sign from the middle, put it in parentheses, and square it. On the right, I have to give 6 over 1 a denominator that is 4. So this becomes 24/4 plus 9/4, which is 33/4. With me so far? Now I square root both sides of the equation, putting the plus and minus on the right. The square and the square root cancel on the left, so I get x minus 3/2 equals, split that up, and it's square root 33 over square root 4, which stays square root 33, but the bottom simplifies to 2. 33 would be 3 and 11, which are both prime. Nothing repeats, so that doesn't get simplified. And then the last thing I want to do is add the 3/2. So because I can't combine the root 33 and the 3, you've got like really 3 options how you write this answer. One is plus and minus root 33 over 2 plus 3 over 2, just like it's written. The other, combine them because they have a like denominator, plus and minus root 33 plus 3 over 2. And the third is just switch the order, which is probably what any kind of standardized test with a multiple choice answer would have it written as. So that last one. All right, go to 6. Step 1, bump the 1 to the other side. Step 2, there's something there. Whatever's on the front of that x squared, which in this case is a 9, we're going to divide every single term by it. We want to get rid of it from the x squared. So I divide it here, I divide it here, and I go to the other side of the equal sign and I divide it there as well. So it's gone from the x squared. 12 and 9 are both divisible by 3, so this becomes 4/3 x equals 1/9. Now comes the real fun part, right? 4/3 divided by 2 squared. Because I have to take the b, divide it by 2, and square it. The easiest way to do these when you have like the fraction divided by the 2 is change that so that it's multiplying by a half. That's the same thing, right? Dividing by 2 and multiplying by a half are the same thing. So this is gone. And 2 goes into 4 twice, so this becomes 2/3 squared. So we took the middle term, divided by 2 or multiplied by a half, and then squared it. And you get 4/9. You're going to add that to the left and to the right. On the left-hand side, we've made it a perfect square trinomial. We square root the x squared. We square root the 4/9, which means square root both. That's 2/3. Remember, it goes back to what was in the parentheses before we squared it. Take the sign from the middle, put it in parentheses, and square it. Equals on the right-hand side, 1/9 plus 4/9 is 5/9. And then I even root property. Square root both sides, putting a plus and minus on the right. I get x minus 2/3 equals, this splits, so square root 5 over square root 9, which becomes square root 5 over 3. And then my last step would be to add that 2/3. So I get x equals 2/3 plus and minus square root 5 over 3 if you switch the order. 2 plus and minus square root 5 over 3 if you combine them together, and any one of those three would be taken as an answer. Again, if it was multiple choice, they usually like to write it as the last one. All right, so what's step 1? Move that 5 over. So I get 3x squared plus 2x equals 5. Second step. Divide everything by 3. I got to get rid of the thing that's on the front of the x squared term. So I get x squared plus 2/3 x equals 5/3. Now, find out what's missing, right? So I take the 2/3. I divide it by 2 and I square it. Dividing by 2 is the same thing as multiplying by a half. So then the 2's cancel, and that actually is just 1/3 squared, which is 1/9. I add it to the left and to the right. Then I square root the x squared. I square root the 1/9. I take the sign from the middle, put it in parentheses, and square it. And then on the right-hand side, I've got to give it a like denominator. So I'm going to multiply this by 3 and 3, making that 15 over 9, and that becomes 16 over 9. Even root property says square root both sides, putting a plus and the minus in front of the right side. And I get x plus 1/3 equals, the square root of 16 is 4, and the square root of 9 is 3. So you can actually simplify that out. and then subtract the 1/3. And because there's no square root, I can keep going. 1 is a negative 4/3 minus 1/3, and 1 is a positive 4/3 minus 1/3. So I get negative 5/3 and 3/3, which is 1. How many of you at least got to like this step? Like when we go to after we square root and then you add the one or subtract the 1/3, but just didn't keep going. Okay, not awful. Questions? So again, because there's no square root in this answer from the beginning, this was factorable. 3 times negative 5 is negative 15. Factors of negative 15 that sum to 2 are 5 and negative 3, right? So like always check, is it easier to factor it out if you have that option? There are going to be 2 on your test that say complete the square and you have no option. But some just say solve.
I'm confused on what we did for the.
I'm going to go to 10. And then we'll go back. Maybe we'll save those for tomorrow. Yeah. Okay. So when you look at 10, right, first of all, it's a negative x squared. So I'm going to still do the first step the same. I'm going to move the 5 over. I get negative x squared plus 3x equals negative 5. And then even though there's not a number on the front of that x squared, there is something there. Yeah. So now there's a negative on the front. So again, even though there's not a number there, it has to be a positive 1 in front. There can be nothing in front of that x squared. But these are super easy. All you have to do is just divide by negative 1, which just means change all the signs. And I get x squared minus 3x equals 5. And then everything from here on out is the same. I take that second term, which is a negative 3. I ignore the sign. I make it 3 divided by 2, and I square it. 3 divided by 2 squared becomes 9/4. I add the 9/4 to the left. I add the 9/4 to the right. On the left, I'm going to factor square root first term, square root the last term. Take the sign from the middle term, put it in parentheses, and square it. And then the right-hand side, I have to give it a like denominator. So 5 over 1 becomes 20 over 4. And I get positive 9 plus 20, so 29 over 4. And then use the even root property. Square root both sides, putting a plus and minus on the right. I get x minus 3/2 equals plus and minus square root 29, which does not simplify, over square root 4, which is 2. And then add the 3/2. So I get x equals, and you can leave it as plus and minus square root 29 over 2 plus 3/2. You could put it all together in one fraction, and you can switch the order. All 3 of those would be right. Let's say, because this does happen at least once in the homework, let's say when you go to square root, the other side of the equal sign has a negative, right? So like it says x plus 3 squared equals negative 10. And then when you go to do your even root property, you square root both sides. What happens when you try to square root a negative 10? Can you square root a negative number? No. So this would be one of those does not exist or no solution kind of questions, okay? If you're going to square root and it's negative, there's an imaginary root there, which we're going to get to in the next section, but not before your test. So you would either, on homework, it's a DNE. I don't know why WebAssign likes to flip back and forth between no solution and DNE, but on homework, it's DNE. It says it in the directions. If that were to happen on your test, you would just write no solution, okay? You cannot square root a negative number, so there would be no real answer there.